Speaking of which, we should probably do some problems. Go ahead, get your regents out. We're going to have plenty of time here today to do the notes, so might as well get a few problems in. Go ahead, read through number 7 as I'm setting a few up here. Make sure you have your calculators out. Okay, 7. What's angle F to the nearest degree? Angle F to the nearest degree. Well, here's the problem right away, guys. If I'm going to find angle F, I have no information about triangle DFE. No information. But as I read it, what do we find out about the two triangles? They're similar to each other, which means what about all their corresponding angles, not sides? What do I know about corresponding angles if two triangles are similar here? Let's start 12, corresponding angles. No 12 here. I have a feeling I'm going to do this a lot today. 2. They are congruent to each other. So angle F, the one I'm trying to find, same exact measure as C. F and C are congruent because they're similar. So now let's find angle C. All right. Only way we're going to find what it is to the nearest degree is we're going to need SOHCAHTOA. Right triangles. All right, I can use SOHCAHTOA. All right, what's the 15 and the 17? Opposite, adjacent, hypotenuse. Give me some labels here. Give me a few labels. 6, adjacent for 15, and sorry, Luke, go ahead. Hypotenuse for 17. Yep. So I have A and H. Which one of the 3 ratios should I be using then with A and H? 6 again, Luke. Cosine. Good work. Everyone ready? Cosine. You can put X, C, doesn't matter. Cosine of your angle equals adjacent 15 over hypotenuse 17. Anybody remember, because there's no cross multiplying here. Anytime you find an angle, you don't want to cross multiply. Anybody remember what I need to use on the calc? Inverse cosine, right? Inverse cosine. So angle C will be equal to inverse cosine 15 over 17. All right, inverse cosine 15 over 17. And then I round to the nearest degree. 1, George, what the nearest degree?
28.
28 degrees. Good work, everybody. See, this is why this test is going to be so difficult for us. This problem right here was a predominantly sine, cosine, tangent problem, but it was also similar triangles. All right. Almost all these questions have 2 different topics in one. So we had similar triangles and SOHCAHTOA both in this one. All right, ready for 8? All right, I'm dilating a line. Find the scale factor. Here's my original line, 2y equals x plus 8. What do you think I probably want to do to that line before I start anything? Y equals form. How do I get this one first line into y equals form? Let's go 5. 11. How do I get this into y equals form?
You move over Yeah. You divide it by 2.
Divide everything by 2. Go ahead, everyone. Divide everything by 2. So I should get y equals, what's this become here? X over 2. 1/2 x plus 4. So there's that line. Now let's do the line that I get after I dilate. Y minus 1/2 x equals 2. Get that in the y equals form for me. 18. Want to get that in the y equals form? Okay. Oh, go ahead. Not here?
Y minus 1/2 x minus 2. Wait, no.
Get the y by itself.
2 plus 1/2 x.
Get the 1/2 over. Yep. Add 1/2 x over. So you get y equals 1/2 x plus 2. All right, we want to know what I dilated by now. All right, what did I dilate by? Now, take a look. And we should have known this from the beginning. What do you know about your slopes? Same slopes, which means what about these lines? They're parallel. Anytime you dilate, lines stay parallel. Anytime you dilate, lines stay parallel. So how are we going to figure out what I multiplied by? I'm going to look at the y-intercept. It was 4, but now it went to 2. So is it getting closer or further away from the origin? This is getting closer, so I know that my scale factor cannot be bigger than 1 because I'm getting closer. If I got further away, yes. All right, how much closer am I getting? 4 to 2. From 4 to 2, I'm getting half as close, or 4 times a half. So my scale factor is 1/2. You always look at the y-intercept because the slopes aren't going to help you because they're always the same. And let's go to part 2 now. I'll let you guys just look at this. 26. Try to do 26 on your own here. Help Diego out. Not enough information to use Pythag here, but it is a right triangle. Okay, while you're working, what did you end up doing for this problem? 15?
I did 38.
Okay. I have opposite. I have hypotenuse. It's a right triangle, so I can use sine 38 equals what? Keep going.
Equals 24.5 over x.
And there you go. All right, and then I end up, put that over 1. Sine of 38 times x equals 24.5, and then divide both sides by sine 38. And then pay attention to the rounding directions to the nearest inch. What did we end up with? Let's go 9.
40 inches.
40 inches. All right, all good? Okay, let's put it away. Get a couple more done tomorrow. All right, pyramid cone today. Yesterday was BH and pi r squared times the height. A little bit different today, so if you want to look, can you guys go look back in your reference sheet for me? Find volume of a pyramid for me. Volume of a pyramid. Volume of a pyramid. When you find it, can you let me know what it is too? There we go. Can you help me from yesterday? What's capital B stand for again? Capital B is my 7. Area of the base. Usually it's a square, but we've seen hexagons, right? We've seen hexagons. And what's H stand for? Because I just don't want you to say height, because I got a lot of heights here. Remember the pyramid theory? Mission Impossible height, slant height. What's H here? 15? That's L. L is slant height. This is the height of the pyramid, the altitude. So everyone good? That's apex down. Remember, you're at the top, you have nothing but a rope, and you drop it straight down. There's your height. There's your height. All right, let's just do a quick basic problem of a pyramid, volume of a pyramid. All right, what shape is the base here? What shape is the base? It's 8. What shape is my base here? Square. How do you find the area of it? 10 times 10. All right, real quick. Can I use that 13 as the height? 16. Can I use that 13 as the height? Nope, got slant height. That's slant height, right? So remember from our pyramid days and surface area, I make a right triangle out of it and do Pythagorean Theorem. All right, so h squared plus, somebody finish the rest of Pythag for me. 18, what's this other leg here? Going to be how long?
5.
Good, half the base. Half the base. We assume half the base equals, and there's my slant height. Go ahead, height of the pyramid here. 16, what'd you get for the height? When you're ready. 12, good work. Let's plug it in and go ahead and find the volume. $400 cubic inches. Remember, we're cubic inches. Any questions? All right, there's a basic one. Let's go a little more advanced now. I have a regular pyramid that has a square base. Be careful. It says the perimeter is 36 inches. It's a square. The perimeter is 36 inches and the height is 15. What's the volume? All right, let's talk about capital B. What is the area of this? I know the perimeter is 36, but what about the area? All right, what about the area? So the first thing's going to be is, what's one side length then? What's a couple sides of this square? The perimeter is 36. What are the side lengths? 14 side lengths. 3 side lengths. If that's perimeter is 36. 9, good. 9, divide, not 6. Divided by 4 is 9. So it's going to be 9 by 9 for an area of 81. And they tell me the height already is 15. We're good. Oh, anybody got this one? 40, 40, 400, 400, 5. All righty, looks good. Good so far. What's up next there, George? Oh, I don't know. Anybody in global here? Yeah? Talk about the Great Pyramid here? Even though I know it's pronounced Giza, I'm sure, but I'm going to pronounce it Giza. Hopefully that rubs people the wrong way. That makes me happy. All right. I heard something. Oh, sorry. It's like a buzzing sound in my head. So I'm giving you guys the volume of this pyramid and a height of 146.5. What's the length of one? Ooh, wow. We're in for it here. All right, so volume, 1/3 area of the base times its height. That 2.5 million we're going to plug in for the volume. Everyone see we're going to solve for capital B here because they give me the height as 146.5. That won't be my final answer because remember, that's just the area of that square. We're going to find the area of the square right now, and then we'll figure out how do I get a side from it. All right, so your first move to get B by itself. 3. Zella, what's your first move to get B by itself? All right, I'm fine with that. Let's multiply both sides by 3. That gets rid of the 1/3. 146.5B. We're not rounding, right? Okay. 7776828. Then divide both sides by 146.5. And here's the area of the base, 53,084.15017. There's the area of the base. Again, not perimeter, not like the last problem. Here's the area of the base. The area is equal to this right here. So your suggestion on how I can find one side, think about it. I don't want to divide by 4, that's perimeter. The area is 53,084. What do I do to find a side then? And remember, the sides are all the same. So x, x, and I do x times x to get the area. Thoughts? 16? Okay. Right now, Via, how can I find the area if I know both sides are x? What would I do? Okay, so x squared equals this area here. How do you find a side now? Now you take the square root of both sides. Okay, so I'm going to take the square root of my area to find a side. And that's going to end up being just nearest meter, 230 meters. So watch it if you do a perimeter versus area. All right, Cone, hook me up with it. Go back to your formula reference sheet. Cone 6.
Cone is 1/3 pi r squared.
Yep. Times.
Pi r squared times pi.
Yep. Guys, it's just BH. That's all it is. It's still 1/3 BH. Just B is a circle, pi r squared. All right, I hate doing this to you, but I want to make sure get more practice with the regions on this. 2 answers. Part A's answer is going to be left with a pi in it. Part B answer is going to be in nearest 10. All right, here we go. 1/3 pi r squared times the height. 1/3 pi. Problem, I don't have the radius given. But to find it, 5, 19, Pythag. Go ahead, everyone. Pythag. To find the radius. 15 squared plus radius squared equals 17 slant height squared. $10. When you're ready, Josh. R. 8. Yep. There you go. Height 15. Ooh, leave your answer in terms of pi, right? So somebody should be telling me something pi here at the end. $12. No, 12. 9. 320 pi. Looks good to me. Cubic meters. All right, now give me that answer to the nearest 10th now. Just practicing on the rounding. $17.
1,005.3 meters cubed.
Good work, everyone. Oh, yeah, go. Anything else? All right. I'll give you the volume and the height, find the diameter. Wait a second. This formula doesn't have diameter in it. What's the plan of action then? The formula doesn't have D in it. What's your plan then? 15? Okay, let's find the radius and double it at the end. I like that plan. 96 pi equals 1/3 pi r squared times 8. Can we do it right now? What's going to eventually cancel out whether we do it now or in step 2, 3, 4? Pi, so let's get rid of those. One-third r squared times 8. You make the call now. You guys make the call. Tell me where I should go now. Make the call. 15 again. Next step. You times it by 3. Okay, that's fine. You could divide by 8 too. It doesn't matter. It's all going to get done eventually. 8r squared equals 288. And then divide both sides by 8. What's that one? 36? Yeah. So r equals 6. But again, finish the problem. Diameter. $12 centimeters. One more together. Last one's on your own. Oh, the ice cream waffle cone. Perfect. What's the height of the waffle cone? Height of the waffle cone now. Okay, so the volume they give me, 54.54 pi, equals 1/3 pi. What are you plugging in for R? What's going in for R on this one? 19? Oh, half of 6.6, 3.3 squared times the height, which we're looking for, right? All right, might as well do 3.3 squared. 10.89. And we know the pi's are going to cancel out. Your next move. 4, next move. $15, next move.
Divided by 10.89.
All right, divide both sides by 10.89. That's fine. You could multiply by 3 as well. Come on. 1/3 h equals 5. Multiply both sides by 3 or divide by 1/3. H equals 15 centimeters. All right, I love this next problem. Last one you're going to do on your own. How many, here's the gist of the problem here. How many of those cones full with water could I pour into that cylinder? How many full cones of water needed to completely fill the cylinder with water? So remember, this is 2 different formulas. 1/3 pi r squared times the height, pi r squared times the height from yesterday. All right. If you think you have it, let me know. I'll come around and give you the okay or look at it and see what we need to work on. And then once I give you the okay, start the homework. You guys watching the video from home or wherever, there's our final answer.